All right, this is 3.3 completing square. So in that last section there, we went from vertex form to standard form. Now we're going to convert from standard form to vertex form. This is an entirely new process, so pause the video as often as you need to as we go through this. Really take your time with this, okay? So once upon a time, you guys did factoring by grouping, and that was when you grouped like terms. Now, out of these three terms, only two of them are alike, and one with x's. We are going to group those together. Now, the thing that we're going to do here is entirely new. We're going to do the same, and I call it magic math, and so did my teacher, and we're going to stick with it. So we need to find this new value that is going to keep our equation in balance, but also create a perfect square trinomial. Now, if we can't remember what a perfect square trinomial, that's fine. The formula that we're always going to use in order to find our perfect square trinomial is we're going to take the b value. We're going to divide it by 2, then square it. So in this case, it's going to look like 6 divided by 2 is equal to 3, and then square 3, which gives us 9. What we need to do, this magic math thing that I'm talking about, is we add it. We're going to add because we have 2 positive signs there, but we also need to subtract it. Because if we're adding and subtracting something, essentially that means we haven't done anything to it, which is fine, but it's going to help here in a second. So what we do now is we have to kick out this negative 9 because we don't need him. He's not giving us our perfect square trinomial. X squared plus 6x plus 9. Then subtract 9 on the outside of the brackets and plus 5. That lets us combine here, and it lets us factor this perfect square trinomial. And having that perfect square trinomial is really important because if you remember, our vertex form is ax minus p squared plus q. So we need this x minus p squared thing to happen. And that only happens when we factor when we have a perfect square trinomial. So if we look at this, x squared and 1 is a perfect square. We have a plus sign in the middle. So we have a plus sign here. And 9 is a perfect square. Square root it, and we get 3. And this is squared because it occurs twice because it is a perfect square trinomial. We combine the back end here, negative 9 plus 5 gives us negative 4. Now that's a process. You need to think about it, go slow, write out your steps. I would recommend for you guys to try every single one of these after this one. This one's different than the last ones. Follow this one. On C and D, I would encourage you to do them on your own after you see how this next one is done. Okay? So again, we're going to start by grouping together the ones that we can, which is our 3x squared minus 12x bracket, bracket, minus 9. Now, we know that something weird is happening here. We know that there's a 3 here. We can factor that out, and we will. So, 3x squared minus 4x bracket minus 9. Now we have this a value. We have an a value. This a value is going to affect what we're going to do here. So let's find our magic number, our magic math. So 4 divided by 2 gives us 2, and then 2 squared gives us 4. So nothing changes yet. So 3 bracket x squared minus 4x plus 4 minus 4, bracket, negative 9. Now, when we kick this negative 4 out on this run, we need to multiply by the a. So now, and it's only because it's getting kicked out. So 3x squared minus 4x plus 4, bracket, negative 12 minus 9. So this comes here. That's where that number comes from. 3 gets to stay the same. X squared is a perfect square. We get x, negative sign in the middle. This is a negative. Square root of 4 gives us 2, and we have 2 of them, minus 21. So we can see how that's different, that we need to remember this key step. This is a key step. It's got stars around it. Please remember it, okay? So take a second, pause the video here. Try C. C is not that much different than what B was, and D looks pretty similar to A. So take some time, pause, go forth. Okay, so when we look at this, first thing that we should do, because we have no C value, the first thing that we can do is we can factor this out. So negative 5 x squared plus 14x. We need to find our magic number. So you get 14 divided by 2 gives us 7, squared gives us 49. So y is equal to negative 5 bracket x squared plus 14x plus 49 minus 49. Let me close the bracket. Now, again, we're going to adjust in the bracket. So then negative 5, I'm going to apply it to the one written in red. X squared plus 14x plus 49. Close the bracket, and on the back end we get plus 245. That comes from here. Follow the arrows. Okay, y is equal to negative 5 bracket x squared. Nope, not squared because we're factoring now. X is a perfect square, 49 is a perfect square, and we have a plus sign in the middle, so plus 7 squared plus 245. That's one of the easier types of transformation that you'll deal with in converting, so let's keep going. This one looks like just like the first one. Pause, take some time, try it yourself, come back and check what's happening. So y is equal to bracket x squared plus 8x close bracket minus 7, magic math. 8 divided by 2 gives us 4, squared gives us 16. Y is equal to x squared plus 8x plus 16 minus 16, close the bracket, minus 7. Y is equal to x squared plus 8x plus 16 minus 23. So y is equal to x plus 4 bracket squared minus 23. Okay. Then we have a problem solve that we're going to do together really quick. We are not going to do this one because we've already done this. And I don't know how it ended up in 2 spots at once, but here we are. Scroll down. The school dance charges $10 for an entrance fee for 300 students. They predict that if they decrease the price by $1, they would get 10 more students. What is the optimal price to charge? So we are looking for that vertex point again. So let's look at this. How are we going to do this? So we have one thought here that if we charge $10 plus n being the number of students. Then we have a second thought of 300 students minus 10 students based on the price. Sorry, this is price. So then this is a revenue function, so we'll start with R. So multiply this out, we get 3,000 plus 300 and plus 10, sorry, minus where's my n squared? No, we're good. Plus 10n squared. No, minus 10n squared. Minus 100n. Okay. So then we get negative 10n squared minus 200 n plus 3,000. Okay. P is equal to negative 200 over 2 multiplied by negative 10. So then you get 200. No, I have an extra negative in here. Right here. Fixed it. So negative 200 divided by negative 20 gives us 10. So that is the x value chart here. If we think about this logically, when we graph this, this would be price and students, because the amount of students we get relies on the price, so the optimum price to charge is $10. That should be it for this one. Go through. Questions are at the bottom here. If you have any questions, please post it on the Google Chats or email me directly if that's not fast enough for you. If you find any mistakes in the work that happened in the notes, please let me know as well.